All right, welcome back to the channel. We're going to discuss the future of forensics and where we go from here in the world of forensic science and true crime. So, the future of forensics and its challenges. Potential new methods. As we look to the future, the field of forensics is poised for exciting advancements. One potential method on the horizon is the use of nanotechnology. This technology could enable forensic scientists to analyze minute quantities of evidence with unprecedented precision. Imagine being able to extract DNA from a single skin cell. Another area to watch is digital forensics, especially as our lives become increasingly digital. The integration of artificial intelligence could help in analyzing large data sets from digital devices more efficiently. AI algorithms may soon be able to predict criminal behavior based on data patterns, providing law enforcement with crucial insights. Upgrades to current methods. Current methods are also seeing upgrades. For instance, next generation sequencing is enhancing DNA analysis, allowing for faster and more accurate results. This means cold cases that have remained unsolved for years might finally see resolution as new techniques come into play. Additionally, the development of portable forensic tools will enable law enforcement to analyze evidence on site, speeding up investigations. Imagine officers at a crime scene being able to obtain instant results for crucial evidence rather than waiting days for lab analysis. The role of improved forensics in true crime. Improved forensic methods have a profound impact on true crime investigations. They not only help solve cases more efficiently, but also ensure that justice is served accurately. Advances in forensics can lead to more exonerations or wrongfully convicted individuals. Can lead to more exonerations of wrongfully convicted individuals, restoring faith in the justice system. Moreover, enhanced forensic capabilities will allow law enforcement to tackle emerging challenges such as cybercrime and environmental crimes, ensuring that they are equipped to handle a wide range of criminal activities. Next, we're going to dive into lesser known types of forensic evidence: hypnosis and other techniques. While we often hear about DNA or fingerprint analysis, many lesser known types of forensic evidence play a crucial role in investigations. One intriguing method is hypnosis. This technique can be used to help witnesses recover memories of a crime that they may have forgotten or repressed. However, it's essential to approach hypnosis cautiously, as it can sometimes lead to the creation of false memories. Despite this risk, it can provide additional context in investigations when used appropriately. Now we're going to look at a list of lesser known forensic evidence types. Let's take a closer look at some of the lesser known types. First, we have voice stress analysis. This technique measures stress levels in a person's voice during questioning, potentially indicating deception. 2. Facial recognition technology. This method analyzes facial features in images or videos to identify suspects. 3. Odontology. This is the study of dental records and how they can help identify human remains or analyze bite marks. Fourth would be geospatial analysis. This involves mapping and analyzing locations related to crimes to understand patterns or connections. Fifth, we move on to botanical evidence. Plant material found at crime scenes can provide information about the location or timing of a certain crime. Six, toxicology. Analyzing bodily fluids for substances can help determine causes of death or impairment in cases of suspicious behavior. Seventh, we have bloodstain pattern analysis. This method examines the patterns of blood spatter to reconstruct the events of a crime. Now we're going to take some time to dive into the pitfalls of forensic science. Potential misleading aspects. While forensic science is a powerful tool, it's not without flaws. The methods can be prone to error or misinterpretation, leading to incorrect conclusions. It's crucial to approach forensic evidence with a critical mindset, recognizing its limitations. Some real-life examples of misleading forensics. Let's look at 3 real-life examples where forensic evidence has led to misleading conclusions. 1. The case of the bite mark analysis. In the 1980s, bite mark analysis was used to convict several individuals based on comparisons of bite marks found on victims. However, subsequent studies showed that bite mark analysis lacks scientific validity, leading to wrongful convictions. In one notable case, a man named Ronald Cotton was wrongfully convicted based on bite mark evidence. Years later, DNA testing exonerated him, showcasing the unreliability of this method. Second, we have hair analysis issues. For decades, hair analysis was used to link suspects to crime scenes. However, it was later revealed that the methods used were not scientifically valid. In a high-profile case involving the FBI, hundreds of convictions were called into question after it was determined that hair comparison was often subjective and flawed. Many individuals were wrongfully convicted based on this unreliable evidence. Third, we have eyewitness testimony. While not a forensic method in the traditional sense, eyewitness testimony is often considered a form of evidence. Studies have shown that human memory can be incredibly unreliable. In the case of Jennifer Thompson, she mistakenly identified her SA assailant, leading to the wrongful conviction of Ronald Cotton. Years later, DNA evidence exonerated him, highlighting the dangers of relying solely on eyewitness accounts. In conclusion, the future of forensics holds exciting possibilities, with new methods and upgrades to current practices that can enhance true crime investigations. Lesser-known types of forensic evidence can also play a significant role, providing valuable insights. However, it's essential to recognize the potential pitfalls and misleading aspects of forensic science, as evidenced by real-life cases. So, I'm interested in some areas of forensic science that are being worked on that we haven't really heard of yet. We've covered kind of some of those in the beginning of the video, but I'm curious whether there's any more. What are some areas of forensic science that have yet to be developed, that are working to be developed? Forensic science is continually evolving, with several exciting areas currently under development. So we talked about next generation DNA sequencing, which is where advances in DNA sequencing technologies are making it faster and more cost effective to analyze genetic material, which allows for more detailed profiles even from degraded samples. We also talked about digital forensics. With the rise of digital technology, methods for extracting and analyzing data from computers, smartphones, and other electronic devices are being refined. This includes recovering deleted files, analyzing social media activity, and tracking digital footprints. A couple we haven't really gone much into is microbial forensics. This is an emerging field. So this field studies the microbial communities present at crime scenes. So, I mean, I've heard of this in other cases where, you know, they estimate the time of death with decomposition, but it seems they're, always working to improve upon that so that they can be more accurate with their time frames. By analyzing bacterial DNA, investigators can potentially link a suspect to a location or determine the time since a crime occurred. Forensic entomology is another one. Using insects to estimate time of death is becoming more sophisticated. Research is expanding into how environmental factors can influence insect life cycles and how this can provide more accurate timelines in investigations. Environmental forensics. This area focuses on determining the origins of pollutants and contaminants. Methods are being developed to trace chemical footprints back to specific sources, which is vital for environmental crime investigations. 3D crime scene reconstruction is another one. Technologies such as laser scanning and photogrammetry are being used to create detailed 3D models of crime scenes. These models can assist in investigations and be used in court presentations even. Next, we have toxicology advances. New methods for detecting a wider range of substances and bodily fluids are being developed. This includes improved tests for synthetic drugs and novel or new psychoactive substances. Now, next we have facial recognition and biometric analysis. Enhanced algorithms for facial recognition are being developed, making it easier to identify suspects from surveillance footage. Similarly, advancements in biometric identification, like gait analysis, are gaining traction. Ninth, we have artificial intelligence and machine learning. Interesting. These technologies are being integrated into forensic analysis to improve pattern recognition, predictive analytics, and case management, streamlining the investigative process. Now, 10th, we have cognitive interview techniques. Research into interviewing techniques that enhance the memory recall, particularly in eyewitnesses, is advancing, aiming to improve the reliability of witness statements. These developments promise to enhance the accuracy and efficiency of forensic investigations, ultimately leading to more effective law enforcement outcomes. What is the future of forensics as a whole? In two sentences. The future of forensics is poised for significant advancements through the integration of cutting edge technologies like artificial intelligence, next generation DNA sequencing, and digital forensics, enhancing the accuracy and efficiency of investigations. As these innovations unfold, they will not only solve more cases, but also improve the reliability of evidence, fostering greater trust in the criminal justice system. Thanks for watching.